So in this video, we'll be working on something called Euclidean Geometry. And Euclidean Geometry is some branch of math that's work with shapes, angles, and whatnot. It also works very well in engineering and some other very interesting applications that you'll see throughout the videos. Okay, so this will be just a background if you have done some things, and I hope that we have done something in Euclidean geometry, things like things like shapes. Notice a triangle, this is a square, this is a circle. Obviously, someone who went to school know all these shapes, or someone who have played in Xbox or what, they know these shapes. Okay, it's square, rectangle, and what's not. Someone who knows all the sides here are equal, or someone who knows here R here, this is radius, the circumference, these are sides, all are equal in isosceles triangle, those type of things. So I think I'll remember some very small theories to remember. They call them theories. That I think that you should remember to take the course in Euclidean geometry. Okay, what do you need to remember? There's a shape. Let me just shape like this one. This is okay, and then now, given that this is the same as this one, okay, these are equal sides. Let me just name them so it will be easy. Let me say this was A, this was B, this was C. So given that A B is equals to AC, that implies that angle ABC, and the angle is on the way I'm talking about the angle, like which letter has the angle, should be equals to angle ACB. Look, that's nice. That's very nice to know. We should remember that. Also, we could say angle AB plus C, this angle again, added to angle BAC, this angle should give you which one? Should give you this one. Should equals to angle, let me just call it angle C, this angle here. Okay, also one thing about Euclidean geometry, you need to say some things, give your working, and also conclude with a good reasoning. So you need a reasoning. No? So the reason why I said this, if you want to know why I said this, just have to drag it some size. I need to give you some good reasoning. I'll say the reason is that external angles of a triangle, you can just write them the way I wrote it here. So two opposites in series equals to external angle of a triangle. So you can say external angle of a triangle. That's fine. That's very nice. Then we can build out of that. Also, if we have some two interesting parallel lines, I hope they look parallel, and there's a line cutting those two lines, there'll be something that they call fun. I think fun. I don't like to write fun like this. Let me write fun like this. Fun. Let me highlight some things in my fine that you think you'll find interesting. Math is fun, right? So when I'm saying fun, I mean to say, you see this angle here is equals to this angle here. Let me name it. This is going to be A, this is going to be B. This will be 1, 2, 3. 1, 2, 3. That's meant to be 4. So take note which angle I'm referring to, okay? You'll see here which angle I'm looking at, then you can tell me which one I'm talking about, okay? So for instance, I can just say angle A1 is equals to angle B1. And this angle is equals to this angle. You know the reason is one of these fun. These ones. This one they call it corresponding. Okay, so I want to get a shortcut that they want, because I don't like writing the full sentences in math. It just doesn't feel nice. Okay, let me just call corresponding angles. Why angles correspond? Because line C D, E, F. You have to say why this line parallel, why these things are corresponding. They are corresponding because line CD is parallel to line EF. That's a good reason that we can extract from this. Also, we could notice that angle A1, don't worry if you don't see A1, plus angle B2, they should give me 180 degrees. I'm saying if you sum this angle and this angle, you should give 180, and then we call them co-interior angles. And the reason also, if we put CD parallel to BF, that's a nice one, nah? So what this is other parts of fun, right? Then we can move to the end fun. The end fun, I'll just use this diagram to explain almost everything that I'm talking about. Let me make it smaller. Make sure that if you are following with me, you have notes so that you will need it in the future. So if you notice here, there is a Z here. This is Z, but it's N there. Let me just call it N, but I like calling it Z. On that, I can say that if you see A1, angle A1 is this one, should equals to angle B3, and you will have a reason, right? Reason would be what is it? I think it's alternating. I don't remember. Yeah, alternating angles, and alternating angles should have what? A reason or same reason, because CT is parallel to BF. Alternating angles. So I think I've said everything in fun. What else I think you should remember? The other parts of Euclidean geometry after lines, those ones, there were lines and angles. There's another one called congruency. Congruency is where we're talking about why things are exactly the same, because congruency is not like similarity. Similarity are things that are maybe shapes that are in proportion, but for congruency, things need to be exactly congruent, needs to be exactly the same. You should also give reasoning, because I think the basic of this course is having to say something and also give a good reasoning. For instance, if I can give you a triangle, this triangle and this triangle, and you're supposed to prove that they are congruent, and then do this, all sides are equal, they name this an A, B, C, D, E, F. Then we can say that if I can say line side DE is equals to side, let me say this was B, BC, and try another side AC, because it's also given AC is this one, should equal to maybe, I don't know, ABCD equal to DF. For congruence, you need at least 3 reasons to say things that are exactly the same. So you could come, I've used that one, did I use that one? I can now say AC is equals to FE. With these reasons, I can now conclude these shapes or these two triangles are exactly congruent. And then you need to say a reason of SSS, side. They are congruent with whatever side, same side, same side, same. Okay. And then I'll give another scenario that you could look up for congruency. Okay, I don't draw very well. I could just assume these things will like almost look like they're the same. I'm not an artist. Obviously this angle is the same as this one. This thing is missing from let me go. Okay, I think now I remember. You can say this dot is the same as this one because of something called, let me call this one angle A, or it's center O1, O2 this side. You can say O1 is equals to O2. There is an opening. Vertical opposite is vert up. Alright. Also, maybe it's given this side is equal to the side A, B, C, D. Then I'll say AB is exactly equal to C. What is C, A, B, C, D? It's also given. You have to say a reason. There is on the picture. You could get something that they also give you. There should be 3 things. Maybe I could say you were told maybe this side is equal to this side. So I'll say C O is equals to BO. I'll say that is also given. Then now I can say triangle 1 is exactly congruent to triangle 2. Why is that? You have to say reason, because of side, angle, side. If you notice, this was an angle, this was a side, this was a side. So an angle needs to be in between, obviously, to make it look cool, but there's literally no reason, just to make it look cool. So we'll move to the name of this one. We said this is the ASS, this one was SSS. Then we could look at other congruent cases. Maybe these are on with the right angle. There will be R somewhere on your equation, but not a big deal. If you can do this one, you can do almost all of them. So what else can you do? There are shapes. I won't even do all the videos for shapes. Just know your shapes, and then you'll be able to solve your problems. So this is just part 1 of Euclidean Geometry. The other parts will follow up and the video of which will be on midpoint theorem, its converses, and I think that's all that you need to know for today's class.